Good morning, good afternoon, good evening. We are going to continue with our design of our five span beam. This beam we have designed with system design and Staadpro. Now we are going to do the same design the same beam with the interactive design in Staadpro. So what we do is that we open the already designed analyzed structure. This is analyzed structure which we have already in our previous class, which we have designed using the system design. So you can call back to the previous class to understand how to do the system design. Now I want to do what we call the interactive design in Staadpro, which has this icon. And I click here, interactive and first concrete design, or you click here, concrete design. Now when you click here, the system will take you to another environment where you do your design. So the first thing you do is to type in the job type, the client, the job number, the part, the reference, the engineer that is doing the job. If there is any comment, you make a comment. Now when you finish that, the next thing you do is to create your envelope. Now when you click on envelope here, you come to new envelope and click. Now the envelope we want to create is my beam. So now when you have created it, to get the load that you're going to use in designing this my beam, to get the bending moment envelope, you now select the load that is going to be used to generate this envelope. So we are going to use load here, this one and this one. So move them. Okay, so when you have moved it, you click OK. So this is it, you have created it. So at this point, the next thing to do is to click on group briefs. So since we are designing a beam, we're going to create a brief for the beam, for the system to know that we are designing a beam. So what we are designing is what beam. So we type in beam. So we now you can select column, you can select slab. These are the three structural elements that you can design here. So since we have beam, so the BS code, you have the BS 8110. If you want to work on Euro code, you can select or any other code you want to. So after doing this, you click OK, and the system will require you to set your design information. You understand what minimum cover is to the structure. This is based on fire resistance and the exposure of the building to the environment. You have your maximum aggregate size. So most times, why it's not good to use a small aggregate size when designing, especially in our local community here, is that you design with something like 12 mm or 16 mm maximum, and you go to site and you find out that people are using 20 mm to cast concrete, or something that even higher than 20 mm to cast their concrete. So that is why we go to maximum aggregate size is 20 mm, bonding is 0.5, and this. Okay, now this is our concrete strength. If you want to use predefined loads, you want to make use of exact values, you come here and type in 30 Newton per millimeter squared. Now envelope that was created was my beam. The number of divisions you want in your beam, I just want 4 divisions, or I'll say we'll have 12 spans. So I want each span to have one division, each span to have one division. So I will have six segments. So click OK. So once we have clicked OK, no, we have not completed. So continue. So like you see, I made mistake to click OK. where I'm not true because I've not set my reinforcement, I've not set my shear reinforcement. So I have to go back to edit brief and it comes back. So at this point we go to main brief, main reinforcement. So the minimum size of reinforcement we keep it at for a beam, keep it at 10 mm, and the maximum size is we keep it at 16 mm. Now the this thing for the main bar, the bottom bar we say 12, 12 and 16. So our this we change for the strength of steel, we change it to 110. Okay, so your shear reinforcement center line of support. Okay, so minimum spacing is 25. It will use 250 if you're using my steel. So every other settings are okay. So at this point you click OK. So when you click OK, the next thing you create is your design brief, your new design group. Your new design group is design group 1, design group, design group my, design group my beam. So design group my beam. So you can see that we have created a new design group, and the design group is design group my beam, and the brief is BS810 beam. So once this is done, the next thing to do is to create your members. You click members. So you highlight first. When you highlight, you go to members and say auto form members. So when you click auto form members, the system will automatically use its hand to form the members. When you click on form members yourself, you begin to form the members one after the other. So we use auto form members. So the system has formed the members. So the member is M1, 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 and look at the properties of the member. So we have the member is 1, then we have spans, span 1, span 2, span 3, span 4, span 5, and span 6. So this is the length of each span, and the total length of the beam we are talking about here is 30 meters. So it just been one with 5 spans. So we have done that. So the next thing we're going to do, so we'll go back. So the next thing we're going to do now after creating our members is to now create. So we select our members, we have created them. So having created our members, so we click on our concrete. Look at it, concrete member. So because we want to do a concrete member design, so click on concrete member. So when you click on concrete member, you highlight this one again and right click and say add members to design group. Add members to design group. So I'm going to add members to design group. I click on add. So you can see initially it's showing failed. Why it's showing failed is that we have not done the design. The system have not done the design. So at this point, you click on design and say design now. Now the system have done the design. You can see that everything is okay, but the system is telling us non-standard stick grades cannot fully verified with BS8110. So the steel grade I entered was 410, which is not a standard in BS8110. But the system we still use it to design, but it might not be well verified. So click OK. So the design has been done, and the main bars are all are okay, the shear bars are okay, and the span depth ratio are okay. So all our designs are okay. So if you want to now see all the things you did, the door drawings and the main reinforcement, layouts and everything, so you now come to this place. So this design we have done to the main layout. This is the main layout. Remember, this is our moments. So this is the um, this is our beam. So this is a drawing. You can see it here. This is a top bar. This is a top bar, and this is the bottom bar, and that is the bottom bar. So this is a section of the drawing. So we are going to put it in a more better way. You're going to see how we're going to do it. Our bar size, remember, we chose 16 mm to be the maximum bar size. So we go back. So this is the main reinforcement. So sorry, the main layout. So click on these are main reinforcement values. This is the data. This is the data. This is your moment that was used in your design. This is the bar size. This is 4 Y16 for top bars, 4 Y16 for top bars. For here you have 4 Y16 top, and also 4 Y16 bottom. So this is your moment. This is your AS required. This is your top. This is your bottom. So let's expand it and observe what is there. So this is top reinforcement. This is a AS provided. So this is the number of bars. We have 4 Y16. So bottom bars for here you have 4 Y12. This this is provided. So the same way, so you go. This is a span. This is a 0 meter for span 1. This is the mid span, so span 2. You can see here there is nothing that was provided for the top bar. Rather, what it was provided for the bottom bar, because this is a mid span where you have your sagging moment. While at this point, where the distance is 0, you have a moment of 112. At this point, 0 meter, you have moment of this. At 2.5, you have this. There is no top. So at 5 meter, you have this moment also. So this is how the design have been laid out, span by span, span by span for each span. So this is a span. This is the distance of all the spans. So all these ones are under span 1, while all these are under span 2. So just that way we go through it. So now, so this is the span of the beam. You see where I clicked. Now this stuff here is the same as the stuff here. They are the same. So this is the beam. This is the length of the beam, and this is a hugging, and this is a sagging cover. So now you can click here. This is a shear links table. This is a shear zone table. This is a deflation table, and also. So now finally, we want to see our drawing. we want to see our drawing. So we click here, and this is our drawing. So the drawing, we have all the spans selected. So if we want all the spans to appear on our sheet, so what you're going to do is to select, we have A2, but the scale, let's use 1 is to 100. Okay, 1 is to 100 is too small, so we use 1 is to 75, so that everything will be in there, nothing will be cut off. 1 is to 50, some things are cut off, so we use 1 is to 75, so that everything will be in there. So you can change to A3, paper. Now you can still remain on A2. So everything is captured. So you check your spacing first. First span top 6 meters, second span left, and separation constant for 4 meters. So title block, where do you want your title block to be? To the left or to the right? If you want it to be to the right, you indicate. If you want it to be to the left, to the bottom, this is the title block. So if you want it to be to the right, this is where your title block will appear. If you want it to be to bottom, be to the bottom, so your title block will appear here. So at this point in time, you are exporting this file to AutoCAD. So you must have AutoCAD installed in your system. If you don't have AutoCAD installed in your system, you'll be stopped at this point. You cannot see a detail of your drawing. So at this point, make sure that AutoCAD is installed in your system. So when it's installed, so what you do is to click OK. So you can see the name of the structure 1001. So you save it. It's saving in the document, so you save. So it has been saved. So you can go and open it. Go to my documents. Go to my document, look for structure. Look at it there, DSL file. So you open it. So if you cannot see the drawing, so what you do, you click on zoom, press enter, and say zoom all. So you type here, zoom all. You can see the drawing have appeared on your screen, so you can highlight it. So you can use your zoom in and zoom out. Want to use zoom dynamic. So I use my zoom window. So I will large. So you can see, okay, let me increase, use my zoom window to get the portion of the beam so that you understand. So you can see what we have here. So this is our design. So this is the edge of the beam. So remember, we set that the structure should be divided into 6 equal parts. You can see this is 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, 5, 6, 7. So the structure will be cut into sections into 6. So next time maybe we select just one so that each of the structure will be divided into just one section. So look at it. So you can click here. So these are our top bar. We have 1, 2, 3, 4. 4y16. 4y16. So that is what we have. 4y16. So look at it. The color bar. Look at the top bar. You have 2y16 for the first level, then another 2y16 for the second level. Then you have another 2y16 for the third level. So you have about 6y16 at different levels. So one is the hanger bar. So let's look at how um, so look at it here. This is the first 2y16. This is the second 2y16. And this is the third 2y16. So in all you have 1, 2, 3, 4, 5, 6. 6y16. So that is what we have here exactly. So look at it. So you have the first one, you have the second one, and you have the third one. So you go to the other support, you have the same thing. Now you go to the bottom, you have 4y12. 4y12. So you can equally reduce this y16. Maybe I'm now going for y20. If you go for y20, the number of bars here will be reduced. So that is the essence of design. And when you're using this, it makes it easier. So if you have the knowledge of AutoCAD, you can edit these values to make it your own, to change the text the way you want it, to remove the things you don't want here, and the way they are placed. You can change this. This is your 9 arrow 8. So if you are using y16, so you can change this to y. So if it is your and this one represents the stirrup. So arrow is okay. Arrow is okay. So you have it R. So that's for your stirrup. So these ones are your main reinforcements. So you can edit the values the way you want it. You can change the arrows. You can do anything you want here in AutoCAD. So you must have a good knowledge of AutoCAD for you to use this particular software perfectly. So you can see that the system have done the whole detailing. Is for you to now do one or two of your arrangements and edit things you have to edit, because everything looks so much clumsy. So you change everything, and at the end of the day, you now come up with your own. So thank you for the attention. So if you have any question, send me mail to my email or send me mail to my WhatsApp. Thank you.